All right, let's try to actually visualize that. So this is actually exciting because I already talked about it for quite some time ago. I mean, right, that I want to use the graphics capability of TempleOS in Advent of Code. So I think the time has come finally. So, but we need to learn how to do graphics, right? Because I have no idea how to do it, right? I did it quite some time ago, but I already forgot everything. The cool thing is that we can always just look it up, right? So let's go to the root of the TempleOS and let's find some demos, right? So there should be some demos. So there is a demo folder. Let's go there. So there's definitely something interesting here. There's the graphics folder. Okay, so and what do we have in here? So we have some interesting stuff. Something like 3D poly. I don't really want to go in 3D right now because it looks a little bit complicated for what I'm trying to do. So let's take a look at balloon. Okay, so there's a very small minimal example that does things, and it's kind of weird. So let's actually see. Oh, it's a small, I'm not sure if you've seen that, but there was a small balloon. But it feels like it drew a texture. A classic Commodore 64 sprite. Oh, it just like drew a sprite. So, but this is not exactly what I wanted, right? So I wanted to see something that draws rectangles, right? So the only thing I need is an ability to draw a rectangle on the screen. Okay, so there is bounce or box. Okay, this looks like something that I may use. Look at that. So there's a JR line, JR. Okay, so there are things that start with JR. Okay, so there are things like gr line, GI print, gr rect. Okay, so we have gr rect, and what it does, it accepts the coordinates of the rectangle and CDC, which I presume some sort of a graphics context. And the question is, how can we get a graphics context to do this kind of stuff? Right, so this is rather interesting. So they're using something called DC. DC is passed in here, right? So it's called draw it. And where do we call it? Okay, so draw it. Oh, this is complicated. So we're using some sort of like FS. Oh shit, it is using like special characters and shit like that, like a mega and whatnot. Okay, let's take a look at the at what it does. Holy fucking shit. What the fuck? So yeah, it is capable of doing 3D, so it's literally a box. Oh, it is using like a rotation matrix. It has a built-in rotation matrices for 3D. Holy fucking shit. Wait a freaking second. Who needs GLM? Do you guys know what is a GLM? Right, GLM. It's like the math library for OpenGL and stuff like that. Who needs that? TempleOS has that shit built in. Just straight up, you can use it. Also, another thing I heard that it has like a differential equation solvers that you can use for physics simulation if you want to make a game with physics and stuff like that. It's just like, holy shit. So yeah, so it has a lot of interesting things that you can use. The question is, how can we get the stuff? All right. So there's a settings push. Right, okay, so there's a settings push, doc clear, whatever that's supposed to mean, and then FS. I'm not sure what the hell is FS, but I really want to see. Okay, let me actually jump there. So FS is the points to the current task. Oh, okay, so it points to the current task, right? And basically we can rewrite its method that draws on the screen and draw ourselves. That is very cool. That is very, very cool. And then we can sleep for like 20 seconds or something like that. And I suppose settings push and settings pop, just, you know, the task forms some sort of like a stack. When you start a new task, the settings of the previous one are saved, and then you cancel that task, they are restored and something like that. I think this is basically what settings push and settings pop do. This is pretty straightforward, right? So let's give it a freaking try. So I'm gonna just copy this entire thing, right? Just select everything, and I'm gonna literally adapt that for my case. So I'm gonna go into the home, like so, and let's go into AOC. Boom. So 11. So let me think. So I might as well just comment out everything in here and copy paste everything we've got in here. So let's start the adaptation, right? So let's start the adaptation. I'm gonna remove that. So this is basically drawing. So old R, I'm not sure what the hell is R, but it's actually like saving something. It is saving something that is called R within the context. Then it's probably some sort of a style or whatnot. And then restoring the R. So yeah, in any case, for now, I just want to ignore everything in here, right? So we're going to straight up ignore everything. Right, so this is going to be a box, but maybe we're going to call it visualization. So this is our visualization. So here is some parameters that I don't really care about, but I'm gonna keep them around just in case. So this is a global R, which we removed. And you know what, I think I'm gonna just like straight up remove this thing. I don't think it's very important though. Wait a second. Do I do anything to redraw anything? I think I don't. I think I just like keep scanning the characters and keep sleeping and stuff like that. I think that is literally it. So I might as well remove everything from here. Just a second. Yeah. I think this is a minimal example that draws on the screen. I think so. And then we have to call the visualization. Visualization. Alright, so if I try to run this thing, it is... Okay, it's been like doing something, but it was not drawing anything. Right, you see, it just like doesn't draw anything. So maybe now we should go ahead and try to draw something, right? So what I want to draw, I want to be able to draw a rectangle, right? So I'm gonna do gr rect. Right, and in gr rect, it accepts DC, right? So this is going to be something like DC, then 0, 0, and let's draw a rectangle of 100, right? So you can also set the current color, I presume. So let's go ahead and set the color to red. So this is going to be color red. And if I try to run that, I only wish OpenGL was as easy as that. Imagine if OpenGL was as simple as just this. I mean, it doesn't have capabilities of OpenGL, but I mean, come on. It's just like built into operating system and it's just super easy. How many like loopholes do you have to go through in a modern operating system, in a modern like real life operating system, just to put a goddamn, you know, red rectangle on the screen? Well, through a web, you can probably do that quite easily, but I mean, if you don't want to use web. We should go back to just writing to screen memory. That was actually not a bad idea, to be fair. Yeah. I think writing to just screen memory, interface-wise, is actually very cool. So it could be only just an interface. Imagine if you had like a back buffer screen memory writing, but also hardware accelerated. Something like that. Right, imagine that if it was just an interface, and when you just actually draw that, it was actually would work faster. Or maybe like, it essentially sounds like a fragment shaders, right? Fragment shaders are basically that, but your program is heavily paralleled, if that makes any sense. But yeah, anyway, whatever. So let's actually see if we can maybe make this entire thing animate. Right, so I presume the only place we can store our state is in a global state. As long as you can't just write over other... Yeah, exactly. So that's why I said that it's like interface-wise. So behind that interface, the operating system or some sort of a supervisor basically abstract that away from you. It makes sure that you like no program writes to the same buffer or something like that. It's just like, it's like virtual memory, but like for graphics, right, or something like that. I'm not sure if I make any sense. I'm sorry. Anyway, so let's actually have something like XY, right? So this is going to be XY coordinates, right? And I can use these coordinates to draw a rectangle, right? Can I? I think I can. So this is going to be x, y, and in a loop, right? In a loop, we can just increment x and y by 1, right? Something like this. Right, by 1, and there we go. So it does not compile because y. Right, I forgot to put a semicolon in there. Right. Rest in peace, Terry. Rest in peace, Terry. Holy shit. It's that fucking easy. Holy fucking shit. It's that easy. It's embarrassingly easy. So, what we want to do, right? We need to probably define the size of a single cell that we're drawing, right? So we need to define the size of a single cell. Right, so let's define something like this. Cell, I think they're going to be square, so I'm going to define only one value, and it's going to be around probably 10, right? So this is a cell size. That's what we have. And let me think. So when we start the visualization, obviously we don't need that shit, right? We want to read the input. We are reading the input. And that means now Octo, the global array Octo, has everything that we need to have to visualize this entire thing. All right, so I'm going to start doing the following thing. Oh shit, this one is actually rather complicated. Because we only have 16 colors. I was hoping that... yeah. I remember some of the application used some sort of like a dithering to convey like shades of particular color. Maybe this is something that we can use as well. Or there's even cooler idea. We can indicate the energy level by the size of the rectangle. That's actually very interesting. So the higher energy level, the bigger the rectangle until it just flashes, and they're gonna pulsate, right? So we can make them pulsate, which is also not bad. You guys think? Anyway, so before we can do that, we probably need to render everything. So what I want you to do, I want you to see what is the color, right? So what is red? So red, oh, it's actually an index within the palette. That is perfect. So that makes it actually super easy to work with. So I'm going to do the following thing. I need to allocate a row and column, right? So I'm going to start iterating this thing. So this is a row 0, a row less than n, plus row. And then for a column equals 0, column less than n, plus column. There we go. And what do I want to do here? So just for the sake of testing, we're gonna assign a different color for each cell, just to test things. Right, so I'm gonna do the following thing. I'm gonna do row plus column, right? And the amount of colors that we have is essentially colors num, right? Colors num, not nam, num. Right, so that's how many colors we have in the palette, if I remember correctly, because I actually hacked the color theme, so I kind of remember this kind of stuff. And the next thing we need to do, we need to draw a rectangle. So it's going to be DC. The position of the rectangle is essentially column multiplied by the cell size, then row multiplied by cell size, and then just cell size, right? So width and height is going to be cell size. Right, there we go. And I think that is basically it. So that should draw the whole thing. There we go. So we drew the sort of like the array of octopuses. But the colors right now do not represent any energy levels, and as I already said, we're probably not going to use the colors to represent the energy levels because we only have 16 of these colors. So, but at least now we can control the size of the cell, right? We can clearly see that the size of the cell is rather small. We want to make it a little bit bigger, right? So we have a constant that actually controls all of that, right? So we can do something like 30. So I think 30 is fine in this particular case. Only 10 energy levels. Yeah, we can use different colors for each energy level, but it's unclear which one corresponds to which one. So So it's probably not gonna really look good, but we can try, maybe. Okay, so let's actually use the energy level as the index of the color. Sure, why not? But I think it's basically not gonna look good in my opinion. So let me quickly try to do that. So I can just do octa, row and column, and just literally use energy level as the color. So that's the basically current state. Does it even say anything? I don't think it even says anything, so it's kind of like useless, right? And one of the interesting thing we can do is probably use the size of the thing, of the rectangle, to indicate the energy levels. I think that's a little bit more interesting. So, and we're also going to keep these the sizes of the rectangles centered at their cell position. So how are we going to do all of that? That's a very interesting question. Whoa, TempleOS. Not only TempleOS, but TempleOS with graphics. We're actually coding graphics for TempleOS. In fact, what we're doing, we're just visualizing the day 11 of advent of code, but for TempleOS. That's what we're doing. So, yeah. All right. So let me actually see what we can do about that. So we need to first figure out the center of the square, right? The center of the square. I think what we need to do, right? What we need to do is to have some sort of a function. Let's call it cell. And I want this function to return me the shape, the actual rectangle that I need to draw based on the energy level, right? So I'm going to do I64, and this is going to be energy. And what I wanted to return is essentially X, I64Y, I64W, right? So this is going to be W, and the H, right? And that is basically it, but I also want to give it maybe the position where it should be located, like a row and column, right? Because basically I just want to abstract that away a little bit. So it's going to be I64 row and I64 column. You know what? Yeah, it feels like that having separate function for this kind of stuff is kind of useless, to be fair. Right, because I can just do that in place, so I don't think it's that important. So let's have it like this. So this is going to be I64, X, Y, W, and H, and we can just pre-compute them in here. So, and the color, by the way, has to be something like maybe red. Let's call it red for now. Okay, so the position is going to be a row multiplied by cell. Size, right? So this is basically where we start. So X is going to be equal to, actually not row, it has to be column, right? So this has to be column. And then we're going to have a row, which is cell size. There we go. So, and we're going to start at the center. So that means I need to add cell size divided by 2, right? But I can actually do something like this. I'm not sure if Holy C even optimizes this kind of stuff. This is a very interesting question, chat. Does Holy C even do simple optimizations? Like, imagine that we have a function, foo, right, that accepts some sort of like x, right? So it accepts some sort of x, and to be fair, I think I did a fucky wacky. I want this function to return actually I64, right? So, and unused variable foo or something like that. I64, foo I64x, right, this, okay, whatever, doesn't matter. So let me put it like that. Can I just run this thing, unused variable x, y, and error, there's error at 158. 158, there is no such thing anymore, but that is fine. Okay, so that's the only thing I wanted to do. All right, so I just want to do this. I64 foo, I64x, right? And we're gonna return x divided by 2. So, and I'm gonna simply compile this entire thing, and it complains about like unused variables, but just ignore it for now. Though we can like go ahead and get rid of that, but I have to use my mouse because it doesn't have a good navigation. So, and now you can disassemble this function. You can literally disassemble, you don't need a God bolt for that. There we go. So here we divided this thing by... Is that a shift? Did Holy C compiler just optimized out division by 2 with a freaking shift? I think it does. It actually optimizes it. Okay, so what if I divide it by 3? Right, and it uses idiff. That's actually pretty cool. So Terry actually spent some time writing an optimizer for that. Wow. Divine, truly divine intellect. Okay. All right. So I don't have to worry about that then. That's pretty cool. Okay, so this is a visualization of our nation. So let's go back. I'm gonna uncomment this thing, uncomment this thing, and uncomment this thing. So that means I can just divide it by 2, and Terry is gonna optimize that for me. Thank you, Terry. Very cool. Size divided by 2. Maybe I don't even need parentheses, but who cares? It doesn't matter. I already have parentheses. Okay, so this is where we start, right? So this is where we start, and essentially now we need to offset x and y by the half of the size, right? So we'll have to subtract, essentially, we'll have to subtract half of the size multiplied by the energy level, but we'll need like floating points for that. I think we'll need floating points for that. Also, I want to have something like half of this size, cell size, and let's do something like half cell. It's not gonna okay. Okay, that's fine. That's probably fine. So I need some sort of interpolator, right? So I know that it's F64, right? So it's definitely F64, and this is going to be our interpolator. Then what I need to do, I need to assign it like this, right? So I need to take octa, row, and column, and I probably want to convert it to F64, right? So I want to convert this thing to F64. Let me quickly do that. So I remember there was something like 2F, yeah, there is 2F64. Right, so if I jump here, it takes I64 and converts it to F64. This is actually perfect. 2F64, let's go ahead and use that. 2F64, there we go. And what I want to do in here is I want to actually divide this entire thing by 9. So that will give me, so I probably don't have to do that, right? That will give me value from 0 to the 1. Hopefully, which I can use as an interpolation of our nation. Which also means that maybe these things have to be the floating points. Maybe all of these calculations are going to be floating points. Who knows? Right, so it's going to be 2F64, right? So this entire thing is 2F64. Right, 2F64. Which is another interesting thing. So I'll have to probably do this stuff. All right. I never worked with floating points in Holy C yet, so I'm not really sure, right, how to do that properly. So I think I need to do the following thing. I need to do 2F, maybe cell size, and I'm going to multiply by that interpolator. You know, half of this thing. Right, so this is going to be half of this thing, and this is going to be like this. Size multiplied by t. So that gives me that. So, all right, that's pretty cool. But it's kind of like an opposite, isn't it? So the energy level 0, yeah, so it has to be the opposite one. So that means I have to do something like minus -1 then. Right, -1. So at 0, it has to be small. That means it's okay. So that's actually pretty cool. So, and maybe because of that, I want to actually do something like -1 right here, right? So that should be it. So I don't have to do it like this. Yeah, because I feel like will need to do that all the time, right? I'll need to do that all the time. Okay, so what about W? What about W? W is basically going to be cell size, right? And if it's 0, it has to be 0. So, okay, that means I need to, okay. So, if it's 0, it has to be 0. If it's that, yeah, I see what's going on. I never done floating point in Holy See, so I'm not sure what to expect in here, right? So I'm really not sure what to expect. Okay, so in here, what we want to do is essentially 2 I64X, right? And then just do something like this, 2 I64Y, and then 2 I64W, and 2 I64H. Right, is it gonna... There we go. So this is what I was talking about. So this is what I was trying to achieve, if that makes any sense. Right. Cool, isn't it? And of course, we can now maybe even use octa row column for different colors, right? So now we have different colors, and you can see, as you can see, they're not really like correspond really well to what the fuck is going on. So yeah, well, let me actually see. So this one has to be like 9. Right, I'm gonna go to the sample. I don't know what we are reading. We're supposed to be reading input. Okay, so we are reading input, and the second one has to be very close to 9. So if I do here, yeah, it's like around 7. Okay, so now the moment we're waiting for, right? The moment we're waiting for. What's gonna happen if we're gonna try to animate that shit? Right, so we're gonna do next octa, right? So this is gonna be next octa, and we have to provide flashes, but we're probably gonna ignore it all the time. So it's gonna be just something like I64 flashes 0, and there we go. So wow, what the hell is going on? So I think it has to be a little bit smaller, slower. So let me try to do that. So this is gonna be like 100. Oh, right. Okay. So that's pretty cool. We can make it maybe even slower. There's some rendering bugs in there. Right, there's some rendering bugs in there, but I think they're slowly synchronizing over time. At least everything is growing. Right. Yeah. So are they synchronizing? I think they're slowly synchronizing. So I'm just waiting for the moment when they're gonna synchronize. There we go. They synchronized. Yeah. That's cool. They finally synchronized. Alright. That's the... We can use this kind of capabilities to actually maybe debug something, right, in the future. Maybe I'm going to save this ability to draw the grid for the future uses, right? So when we need to debug like a grid-based stuff. So what if I make it like super quick? So will it synchronize faster? Right, so it is actually maybe 5. They're gonna synchronize. Yeah, it's like, yeah, and they synchronized already. Yeah, that's pretty pogue. So let's put like 120. Though the problem here is that they're not doing that very, you know, very smoothly. They're not doing that very smoothly, unfortunately. But yeah, that's pretty pogue. That's pretty pogue. Okay, so let's do a committee. I don't know, maybe I'm gonna put visualization like comment in here, and yeah. So here's the stuff. So essentially, if you want to play with the visualization yourself, just basically comment part 1 and part 2. Just comment part 1 and part 2, and then comment visualization, right? So I'm going to put this kind of stuff in here. Right, so, and I'm going to just quit this entire thing. And I'm going to sync all of that into the host, AOC 2021. There we go, there we go. Wrong password? Was it hacked already? Okay, so I wasn't hacked, cool. And now, let me take a look. Status, and git add home and commit add visualization for day 11. I'm going to push that right into the repo. There we go. Okay, so, and you can find the source code for like everything here in the description, or if you're watching live, I'm going to copy paste this thing in the chat. So yeah, if you want to play with the source code in here. How much time did it take me to actually figure it out? Like 30 minutes, 33 minutes. All right, that's actually pretty cool. That was relatively easy, right? So figuring out graphics, if you know a little bit of graphics in TempleOS, is actually relatively easy. So that's pretty cool. I guess I'm gonna call it a day for now. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you on the next Advent of Code session. I'm not sure if I'm gonna stream tomorrow because I've been streaming like non-stop for quite some time, so maybe tomorrow I'm gonna take a day off. But then we're gonna continue solving this entire stuff. And now we have a pretty cool tool under our belt, right? I hope I pronounced that idiom correctly, that we can use for future things, right? So because now we know how to visualize stuff, and we can use that for debugging, right? Which is absolutely freaking cool. All right, thanks everyone for watching. Thanks everyone for all of the subscriptions, and maybe we should rate somebody. I don't know. Is anyone doing anything epic on a software and game development section? Oh. Okay, come on Twitch, you can do that. Pilate is streaming, but he's streaming RuneScape or something. I don't know. So I hoped he streams like programming or something. Jessica, we already rated Jessica. Probably all. I don't remember who that is, but they're streaming Hairdresser's API. I don't know. Doesn't sound like Advent of Code to me. Bruh. Epic bruh moment. Advent of Code. What language is it? I don't know. Doesn't say the language, unfortunately. I see day 11. C#. A dream team. It says Rust. It said Rust? I didn't see. Where's the Rust? Should we raid Rust? I didn't see Rust. Where is the Rust? Oh man, I can't see shit in this mist. Oh, in the tags you mean, right? So somewhere in the tags there was Rust. Like the interface doesn't allow me to see clearly. Okay, so Rust, I will probably raid Rust. Sure, why not? I absolutely love Rust. People who watch me for a very long time, they know that I absolutely love Rust. Rust, I like it better than any other programming language. It's my favorite language of all time. So, of course, I'm gonna raid Rust. It's not necessarily true. But I do find Rust interesting, but I don't think it's a, you know, it's a language that will make me switch from everything else. All right. At least it has a couple of novel ideas, right? Which is quite rare these days. Even Porth doesn't really have any novel ideas, but Rust has novel ideas. Anyway, get ready for the raid, and I see you all next time. Love you. Mwah.